5, 4, 3, 2, 1, 0. All engine running. Liftoff.
Hey, space enthusiasts. In this episode, we'll talk about predicting extreme weather. We scheduled this episode recording a while ago, and it actually was not the plan to make it coincide with Hurricane Ian, but there you go. I guess it's timely. I also hope that all of you who are in Ian's path are or stay safe and sound. My guest today is Dan Harkins, the COO of Tropical Weather Analytics, and he'll tell us all about extreme weather and how their proposed satellite constellation may help us predict it. Enjoy.
My name is Raphael, and I'm an investor and advisor to space companies. Just as a reminder, this podcast is for informational purposes only, and nothing should be taken as investment advice. This podcast is sponsored by Avionics, a satellite manufacturer and mission integrator. Their technologies enable many space companies worldwide to offer services that improve life right here on Earth, such as providing global connectivity, conducting Earth observation, or contributing to scientific discoveries. Check them out, and also check out my episode with the CEO and co-founder. Sadly, I am not a rocket scientist, but I'm an alumnus of the International Space University. ISU offers a number of educational programs about space worldwide. Check them out at isunet.edu. And just some final things before we start the episode about ourselves. If you enjoy the podcast, please leave us a 5-star rating on your favorite podcast platforms such as Apple or Spotify. If you want us help expand our work, you can do so and support us at www.patreon.com/Space Business Podcast, and we'll also put that link in the episode notes. And lastly, you can follow us on Twitter at podcast_space. Hey, space enthusiasts, welcome back. It's time for another episode of the Space Business Podcast, and it is a business episode, which means we're interviewing an executive from a space company. Today, I'm very happy to welcome Dan Harkins, who is the COO of Tropical Weather Analytics. Welcome, Dan.
Thanks for having me on, Raphael. It's great to be here. Great to talk about what we're doing.
Yeah, I'm actually very interested in talking about weather. It's something we should have done already. We've done to some extent in some other episodes, but never really on a sort of, pure play basis, if that makes sense. So, Dan, why don't you start off giving us the elevator pitch on Tropical Weather Analytics, please?
Oh, it's a long history, but we're commercializing a technology. So basically our vision for this mission is to leverage about $100 million worth of NASA funding into providing earlier, more accurate hurricane forecasts, but also by collecting polar wind data in other areas that just aren't covered by wind measurements, we can improve all weather forecasts. So, our mission is just to save lives and save billions of dollars worth of damage because of climate change. Even if we, stop the missions right now, we still have the problems of what's happening at the moment. And you're even seeing it right now. There are several hurricanes going. There's just not enough assets to predict. So we just need to improve that picture and have more observational capability. And that's what we're trying to bring.
Yeah, so it's funny you mentioned NASA. I'm going to ask you about that 100 million in a minute as well. But NASA, of course, is trying to currently still launch Artemis 1. And I think that has currently been delayed because of uncertainties about the weather. And it seems to be going kind of back and forth. So it seems like even NASA doesn't have sort of a perfect weather prediction capability.
Well, in fact, not just Artemis, but they launched hurricane satellites, CubeSats, not too long ago. And unfortunately, those failed. Those were using something very different than what we use. We are not sensor-based. Ours is based on 2 satellites, just an off-the-shelf space camera. And it's all in the processing of how we get the images, collect the images. And then it's our algorithms and our model of hurricanes and vertical and horizontal winds.
Okay, so let's take a step back. When we're talking about forecasting, I guess there's obviously different time frames, right? And so NASA, when I was joking about Artemis right now, that seemed to be like a time frame of like, a few days out, where there was a lot of uncertainty. What's like state-of-the-art accuracy and what time frames at the moment?
Well, right now it's up to the minute, but the accuracy is not all that great. You can get pretty good with hyperlocal forecast. There are several commercial weather companies and private weather. Not private weather, but government-funded weather services that can provide that kind of granular resolution. But the only way to actually improve that, you can improve it through algorithms and modeling because there's private weather companies that do that. They're all different, obviously. They don't all have the same models, but you're only as good as the information that you can collect. And right now, the big key piece missing is horizontal and vertical winds all across the globe at high resolution. And that's what we'll be bringing. We call it 3D winds. It's actually more like 4D because of time. But that's really one component that's missing, because wind actually drives a lot of the weather patterns, as far as the accuracy of the forecast. So right now you might have 2 days accuracy. We think we can improve that by about 30 to 40% with our wind data.
And just to ask a general stupid question about this, I mean, isn't it sort of like weather forecasting and including hurricane forecasting? I seem to remember a long time ago, I read a book about chaos theory and the origins of chaos theory. And I think there was a guy at MIT, what was his name? Lawrence, I think. And he basically discovered chaos theory because he's trying to predict the weather and found out that like very small changes in initial conditions can make a huge difference. So have we just gotten much better? I think this was in the 60s. Have we just gotten much better? Do we have better data, better algorithms, a bit of both?
There's certainly better everything. There are more assets, whether it's satellites, weather stations on the ground. We've definitely gotten better since the first weather satellites have gone up. And the GOES satellites, which most people do rely on, that NOAA runs and NASA, those GOES weather satellites are really the bedrock of the weather forecast, and they're always improving that constellation. They just launched one maybe about a year and a half ago, the latest one, but those will be up more of those. But having said that, the GOES are geostationary satellites. We are going to be in LEO, the low Earth orbit, and in a polar orbit. So one area that's not covered, and you could probably pretty much Google it right now, is if you wanted to see the North Pole or the South Pole from satellite images, you really wouldn't get all that much in return. You could pretty much see it everywhere else on Earth, but not there. So the wind data is just not measured at these poles. And the polar vortex is basically like a hurricane that never goes away that's happening at the north. Sometimes that splits, sometimes it becomes unstable, it hits the jet streams, and then extreme events occur, like the Texas freeze, for instance, was one where the polar vortex went really far down south and Texas froze over. It was billions of dollars, almost 700 people died. The New York flooding was kind of the trifecta of what we measure. It was the polar vortex hitting the jet stream supercharging a hurricane, and then dumping all that rain. And that was seen coming, but not to the accuracy and leveling, making the cone of uncertainty a little bit smaller so that you can really pinpoint. Because the first thing that I think people, when I talk to, is, well, hey, how do you sell weather? But B, you can't do anything about weather. So weather's just going to happen and you just have to accept it. But there's a lot of things that can be done. Sure. Even a 12-hour notice, according to a lot of studies, is, you could save about 30% of damage cost. I mean, you can harden the infrastructure, you can evacuate people more reliably. Certainly that's one big problem. Is it just human nature? If the weather is wrong, they're more reluctant to leave the next time if the forecast is wrong to evacuate. So those kinds of things of locking down, getting that accuracy and reliability that people can trust is going to be huge in the future.
So just taking a step back, you've mentioned Polar Vortex there a few times, and so we're a very non-technical podcast. Can you just give us sort of quick explanation of what a Polar Vortex is and what its relevance is?
The Polar Vortex is basically like a hurricane at the pole, at the North Pole. It's a swirling mass of wind it's almost always there, but it drives a lot of global climate patterns and weather patterns. So when this cold air either splits or disrupts, it goes into the jet stream, and then it's really transferred to around the globe. What happens at the poles really drives most weather patterns to a degree.
Okay, so is that sort of a constant hurricane you said? Is that just simply because of the Earth's rotation?
Yeah, exactly.
So this seems to be pretty relevant. And why has nobody sort of done this before, you think?
It took a long time to get here. Our mission started out as Project Ramos way back in, I think, 1999 range. And those were extremely large satellites, in the 2,000 kilogram range. In subsequent times, obviously, the small satellite market has emerged. Other satellites actually went up that got a temperature measurement that we need, which we now get for free from that satellite. So our satellites got smaller and smaller. And so as we transitioned from the company at the time was called Visidyne before we became Tropical Weather Analytics. As we were making that transition from that weather satellite, NOAA and NASA and the Department of Defense came along and started funding the hurricane work. And those were just small little bits that they needed for 3D wind measurements that we could improve upon. And those are small things that just over time, about 10 years, that they needed to improve their measurements. And then when the modeling that we had produced proved to be extremely effective, NASA then funded a mission which they ran on their own, and that was the CIMUS program. And that was just looking at tropical cyclones. And that ran about 5 years, almost 6 years, just to prove our technique. And then at that point, the research part was over and we needed to commercialize. And we at that time, were just focused on hurricanes. Our sole thing was, well, we're going to provide earlier, more accurate hurricane prediction. We think 12 hours. We had some case studies up on our website if anybody would be interested. But as soon as we started talking to meteorologists, because we were all imaging guys and space guys, we didn't know much about the meteorology side of things. That's where NOAA and NASA came in. They knew how to apply the data that we were producing for them. So when we started talking with the meteorologists in the community, they basically told us that it's really, hurricanes don't happen all that often, even though right now they're happening a lot this specific week, but they are fairly rare, 20, 25 a year. But what they told us was nobody's measuring the polar vortex, the polar winds. If you just applied your model to that would improve the general weather forecast, and that would be extremely more valuable than anything you can do with hurricanes.
Okay, so what you guys are bringing to the table, I guess let's split this up. So there's obviously an analytics part, but let's leave that to one side. Like if we start with sort of raw data, what you guys are bringing to the table that's new, if I understand it correctly, is basically more coverage of the polar vortex than has been done historically, and also this the 3D element, the vertical winds. Is that it?
Yeah, really, the vertical winds is one of the biggest things. The coverage, not just at the poles, but over the open oceans. There are just a lot of places that are actually uncovered by weather stations and traditional weather satellites. So we know that across all altitudes in 3D, we'll be able to map these winds with high accuracy, and that can be fed into weather models. So what we do is we provide three kinds of things. The first thing that we provide is the big data products that meteorologists would then use. So this would be 3D images of the actual cloud feature. So we measure clouds. So any sort of cloud feature, doesn't necessarily have to be a hurricane. Even wildfires, for instance, we could actually apply our model to wildfires. So we take these images, and with those images, there is also a listing numerical data within these images of the wind velocities across all altitudes and what axis these winds are in. So there's only about 300 meteorologists in the whole world that could actually take this data, put it into a model, and produce a forecast. So that's our big data product, which would be a large, monthly subscription for that they could use. And from there, we know that the hurricane forecast, the U.S. is really the only country that has a fleet of Hurricane Hunter aircraft. So we could bring hurricane forecast there's 20 countries that are vulnerable to hurricanes. So we could actually bring an end-to-end solution for them that would be similar to the Hurricane Hunter observations. The big difference between us and the Hurricane Hunters, obviously they fly through the storm. So they get more accurate measurements dropping those songs. However, they don't measure the whole entire storm, and they can't do it as frequently as satellites can. So we'll be complementary and not instead of in the US, but in other places, Japan, India, Australia, the Philippines, they could take our hurricane data, and that would essentially act like Hurricane Hunter aircraft for them at a fraction of the cost. The fleet of Hurricane Hunters costs about $250 million per year just to maintain. We can sell our hurricane data for $10, $15 million per year. And that may seem pricey, but for the amount of damage that can be done and what can be saved, it's actually quite a bargain, and you're not paying for the planes. So it's a big deal there. And then the last thing that we do is we want to package that data so that users can actually do something with it, the everyday person. So imagine that you're a farmer or a stock trader, you have insurance companies. This data can be applied, and they won't know where the wind data came from. All they know is that they have improved weather forecast.
And they don't care where it comes from, right?
Exactly. All they want is actionable weather intelligence that they can use to make decisions and improve their business. So, whether that's like a FedEx or an Amazon or a UPS, for instance, they could really optimize their shipping routes, both ground, sea, and air, just by having this improved forecast and alerts that come directly to drivers, especially wind is one of the bigger ones, certainly on the seas, cargo loss, and just improving routes that can be done as far as maritime cargo goes, and keeping track of these ships a little bit better with the hyperlocal weather forecast. Because oddly enough, the size of these ships, the weather is actually, it's almost different from one end of the ship to the other in some cases.
Yeah. Just take a step back, going to the vertical winds, because I find this fascinating. I mean, without obviously giving away anything that may be a secret sauce or protected or trade secret, can you give us some insight of how we should think about what kind of sensors are you using to measure vertical winds?
Yeah, I think that's the most interesting aspect of this project. And one of the things that drew me to it was that it wasn't about commissioning a new sensor and, being years out, because space always takes a long time. It's always a lot more expensive than you think it's going to be. Things might fail. So what I really loved about this mission when it first came my way was this was basically an off-the-shelf satellite bus that could be purchased. This was basically an off-the-shelf camera that could be purchased. The way the winds are actually calculated is by using a pair of satellites focused on a specific cloud feature, taking measurements of the cloud feature from that angle. You are able to generate a 3D cloud model. We're talking a different kind of cloud, right? But a 3D point cloud of the cloud. That's the best way to say it. And from there, what you have is not just these amazing images that show the detail of the features in 3D, but there's a numerical model underlying all of that in the cloud features. And that's done through the algorithms that have been developed and the modeling that's been developed to calculate that vertical wind and even the horizontal wind.
Okay, I think I got you. So it's not like you're measuring wind directly, you're measuring features, and then through experience, you can basically infer that there are winds going on. Is that it?
Yeah, exactly. So very different from any type of radar, and maybe the closest satellite, although it's sensor based, is the Aeolus ESA's mission, which has outlived. It was a proof of concept. It's outlived its mission life, but it's still going. That's one that's returning wind data from the poles, not quite at the size and not at the resolution that we will provide, but that might be the closest analog to what we're doing.
Oh, while you're mentioning ESA, before I forget it, so I think there's something upcoming, or there's supposed to be something upcoming soon. I mean, as you mentioned, space time frames are always a bit uncertain. That's called the ESA Arctic Weather Satellite. And since we were talking so much about undercoverage of the poles, is that something that's anywhere remotely relevant to what you're doing?
Yeah, it absolutely is. That will be very similar. It's, again, using a different method. So we would say that it's going to be complementary, not competitive to what we're doing. And especially when it comes to weather, the more data points, the more collection you can get, the more observations, the better the weather is going to be as far as forecasting.
If you take that philosophy, does that not mean that sort of like, okay, ideally a model should combine all of these different sources like ESA Arctic Weather Satellite, your source, to produce these models? But just remember, so are you guys proposing to do the models yourselves in-house as well? Or would you leave that to other people? Because there's established weather forecasting companies like Tomorrow.io and people like that, right?
Yeah, exactly. In fact, we have a letter of interest with Tomorrow.io, and that's not a component that we want to deliver because other people have their models and could do it much better. That goes back to there's 300,000 meteorologists in the world. Even from then, I'd say we're really, there's a few of those even have the capability to, run independent models or make their own. So there are great models that exist already, and it's fun. They kind of compete with each other. Maybe the most interesting thing that I found out in the last year is with ESA's Aeolus going offline at a certain point, or the prediction that it will. I got really interested to talk to meteorologists. This wind data is proven to be powerful and really improves the weather forecast. What are you going to do when it's gone? And most of them just were pretty much not using that data in their prediction. I found that kind of fascinating and odd, but I think, that's exactly, you hit upon the point of, shouldn't we collect all these things and have them in one place? That would be the best, I think. But there are also independent assets that private companies have, whether that's weather stations on the ground in their own radar. So to a degree, it's not possible to have everything, but I think this is going to be one of those things that, would over time prove out that you would need it if you're going to run a good weather model.
Okay, but so as a part of my background is being a trained data scientist as well. So the fact that those guys said they're not using it, does that not worry you? Because that's like, why are they not using it? Do you think that's a issue that they are not educated, have not been educated about the relevance, or they think it may actually not be relevant, which obviously would be much, much worse?
Yeah, exactly. It'd be terrible for us if it wasn't relevant. I think I'm not exactly sure. I haven't gotten to the bottom of why they would not, because to me, I considered some of the ESA work to be landmark, changing everything that we might know because of, they did study of with the wind measurements and without, and showed a marked improvement of their weather forecast. So I thought, everybody would adopt this. And that could be, I've heard everything from maybe a timing issue of when you can get the data, how they release the data. It's not as open as a lot of the other satellites. Is my understanding. So, I was surprised that more people were not using it, though, that I was talking to. But I think that would definitely change with us. And in two ways is that I do think that in general, I think there's always a reluctance in space for early adopters, even how powerful the data is, how much it can help businesses. The cost of doing nothing and doing what you already are doing makes people just kind of reluctant to actually, use this new technology. I see it with imaging companies and SAR companies all the time. I feel like they should have a lot more users than I would ever imagine. And then you see their public reporting and you're like, why aren't people adopting faster? This data is so powerful and it's transformative. So I think we will definitely have that too. That's why I wanted to make sure that we had a suite of products that was low cost introductory products to the everyday user, like a farmer or like a stock trader.
Yeah.
It's just an improved forecast that they can use in their everyday life. But, getting people to adopt our technology, we really have to be out front because weather is consumable. It happens all the time. So that's actually a good thing. So what you can do is make these forecasts, and maybe nobody's listening to you at the time that you're forecasting, but after the events, you can show, this is what you could have saved. This is what you could have prevented. This is how this could have helped you, either a business case or, reducing the humanitarian aspect of weather. And that just happens all the time. So over time, companies are going to see that, we can actually save money. We can actually make weather work for us. So we really have to, that's a big focus for us is going to have to be proving it as we go, as weather changes.
Yeah, no. And in fairness, I guess, the more I think about it, and I've been speaking to quite a few EO companies as well, I think we're still early on in EO in the sense that on the customer side, there's very often still a lot of education to be done. And then on the side of people who are providing the insights, it's just large parts of EO data are still not very user-friendly, right? It's like you kind of alluded to that, right? Sometimes the formats are weird. You have to do a lot of data fusion and wrangling and all of that. I mean, maybe the explanation is as simple as that, but it hasn't been used more.
I think for sure. And I think, the one aspect that is advantageous to us is that weather just happens to so many industries. And it's so understandable. And again, it's consumable. It happens all the time. It goes, and then it happens again. So you can really make the case a little bit better from a business standpoint, or, again, every government, every military relies on weather too. So as you're building up the data of this is what happened, this is what you could have prevented, this is how you could have profited, other companies for Earth observation may not necessarily have that proof, on a rolling basis that we can provide with weather. And that's going to be for every weather company. That could be Tomorrow.io, for instance, will do the same thing. And that's why I always worry about the big data for us is a little bit more interesting because the meteorology community meets a lot. They have they're focused and we know where to get them. We know where to talk to them and get in front of them. Whereas in Earth observation, in a lot of other ways, it's kind of like small segments that you have to sort of make your case to all the time. And that's a really heavy sales and marketing and PR lift. I think that's why there's the early adoption isn't quite there.
So you've mentioned agriculture, you've mentioned the military. Where do you guys see your sort of in summary, your key customer segments and where do you think it's going to start?
Well, I think for sure, industries like insurance, we're going to, there's 20 industries that are impacted by weather. We really want to try to focus on 6 that we think we can handle immediately that will be helpful. Oddly enough, we know we will help the satellite industry. quite a bit, because it costs a lot of money to task these satellites and get them on a schedule. And guess what? Clouds are in the way, whereas we're the exact opposite. Clouds are our friends. We need clouds to get our wind data. If there aren't any cloud features, we actually, we can't measure anything. But thankfully, the Earth is covered by clouds, 70% of the time. So we'll never run out of clouds, but we can help the satellite industry quite a bit by having a better cloud forecast, which then means that their window of opportunity to get features for their customers can be improved. So we know we can save them money. So that's a big application for us that I think is just going to improve the entire industry. And after insurance, stock trading, agriculture, certainly maritime shipping is one of the better applications for me that I see, because there's an existing customer base of AIS companies that are providing this service. And having a better weather forecast can help these existing customers. So you plug kind of right into their database of, let's just say, there's probably about 8 to 12 million AIS customers, just off the top of my head, I would say, provided by different companies. So, what differentiates one AIS provider from another one could be a more accurate, hyperlocal weather forecast that helps their ships, help them with routes, help them not lose cargo. You might have remembered the Suez Canal incident a while back. That was wind driven to a degree. And also the weather forecast for really seeing the levels of the water impact shipping rates, how much you can put on a boat, and what you can charge customers. So having that like hyperlocal specific forecasting could help these companies a lot. And again, they're already buying a service, so it's easier to tap into and show the value that can be added with this kind of weather service.
And what's your go-to market? Is it sort of you guys, I think, and you can sort of talk about this a little bit, I suppose. I think you guys planning on flying 2 test satellites, and then you're obviously going to start producing, I guess, first data. Are you sort of waiting for that, and then you are commencing your go-to market, or is there something you can already do, like using third-party data?
We could actually go to market now, because we do have weather partners already that already have developed products that we would love to sell. But we're focused on understanding those product suites, how we can reach the market, and how we can improve. But in order to do that, because what's the differentiator, and I'll say there's 3 big companies for private weather, and those would be IBM's the weather company, DTN, and AccuWeather, and soon to be Tomorrow.io, I would say you could add that into the category. So what's the differentiator of how they produce for their customers? And it's going to be what the better or more reliable weather forecast in the future. That's how they will differentiate. Right now, they're, when I talk to people, they all think they're very similar, oddly enough, which to me, that's not so great. So our go-to-market strategy is we can't necessarily sell the existing products from our weather partners yet, because there's not much differentiator without our wind data. So it's get our first 2 satellites into orbit. Within months, actually weeks, we'll be able to return data products that we can actually package and sell. And so we will first go to the experts that will use this to produce value-added data. And that's the meteorology community for us, that 300,000 that I was talking about earlier. And after that, shortly, we're within 6 months, our next go-to-market strategy would be picking one type of app that already exists, whether it's a farmer app or a stock trading app or one for insurance, something that exists already that we can then plug our data into to improve that, and then expanding that market.
Yeah. I forgot to ask you, when you were talking about industries before, how about aviation? Is that relevant to aviation?
Oh, yeah. I can't believe I haven't talked about aviation. Hugely relevant to aviation for a bunch of reasons. The jet streams, number one. The resolution of the jet streams, the way that those are taken, the balloons, I think, go up twice a day from 4 points. And then obviously the planes themselves measure. But the resolution that's measured is on the kilometer scale. The planes in the jet stream fly closer than that. We are at 100 meter plus or minus scale. So, the difference between a kilometer of uncertainty versus 100 meters of uncertainty is much better. So we're going to have a huge impact on aviation in that way. That would be safer navigation of the jet streams, which you think, well, we're already doing that already and it's pretty safe, right? Climate change says no. It's going to make things a lot worse, a lot more unpredictable moving forward. There's nothing we can do about that. So we got to have something to make that safer. The other thing is, which I just always love to say, is we open up Santa shortcut. Flying over the North Pole, those aviation routes are really not taken advantage of the way they could be. They're shorter, they can save a lot of fuel, but they're dangerous at the moment because of the polar vortex, because of the conditions there, and because of the lack of monitoring. There's not many Arctic stations. There aren't any satellites that are getting the wind data or a lot of the weather data. So that's where we would be a key component, especially for the military. That would be a big deal to open up Santa shortcut. So aviation will be one of our key markets for sure.
Yes, I'm fascinated when you're talking about the jet stream. You mentioned the weather balloons. I mean, is that really what's happening at the moment? Some sort of like globally, or at least transatlantic, coordinated, regular release of balloons?
Yes, for the most part. For the major weather stations, there are 4 points, and they all report to each other. I believe it's in the mornings and later afternoon. But there are weather balloons released all over the world, like twice a day, I think, at certain points. We actually have a nice little map and graphic of all those weather balloons. Hopefully it's made it to our website, but it gets out on social quite a bit. What you notice is that there's just a lot of uncovered territory of the winds. Obviously the weather balloons are getting more than that, by the way, but so I'm not trying to say that weather balloons are useless, but they're limited in range of where they fly, and they're limited in altitude. So we're going to be covering, adding an area of coverage to that. Like I said, it's not competitive. It's certainly complementary again.
Yeah. And I guess I understand the sort of lack of coverage specifically for what you're doing, but I guess there's a lot of EO satellites flying polar orbits for obvious reasons. Is that so? Do you guys actually need your own satellites, or could you host on somebody else's satellite?
So we tried it every which way. That was at first we thought that we could actually do it with one of the major constellations that's up. Mm-hmm. So we're pretty excited because the last thing we want to do is have to invest in running our own satellites, and,
sure.
and those are expensive. They're not as expensive as they used to be, but it's still pretty capital heavy, and there's uncertainty. But sadly, for the pointing accuracy we needed, the distance between the satellites and the communications that we need, there's just not a constellation up there right now that satisfies those criteria. So that's why we're building the first two with an eye towards adding at least 4 more pairs. We could certainly add more, but 10 satellites, again, they go in pairs. So 5 pairs of satellites is our plan for the moment, and what we would love to do. And our goal is to just launch the first 2, return our data product, make any changes that we may need, and then the next 4 pairs immediately. So it wouldn't be a slow growth. We would really want to add those pairs as fast as possible, because the data product becomes so much more valuable with the frequency of revisit time, from 2 satellites to 10 satellites. So that's where we're trying to go with that.
Okay. And so what does your timeline look like? So the first 2 satellites, when are they supposed to go up, and then how you go from there?
Well, hopefully with a little bit of luck, we only need about 14 to 18 months from start to finish to build, launch, and start getting a data product back from our satellites. We're still trying to raise funds. And then from there, we would be 12 to 16 months out for launching the next 4 or 5 pairs. We might have an additional pair, just in case at the ready. So it depends on how things work out for that second launch.
Gotcha. And so you're fundraising right now. How's that going?
We are raising right now. It's going pretty well. We had raised about $500,000 in seed money previously. We're a little bit of a strange company in that NASA and DoD and NOAA has already paid for the research aspect of it. There was more than $100 million invested from there to get us to where we could commercialize. So we really only need $6 million to get our first 2 satellites up and launched and ready. Even less than that if we just count the satellite part of it and not running everything else.
Yeah, sure.
And right now we are actually raising on Space Ventures, which is an online platform that allows small investments so that, companies can do big things. So we've been pretty excited about that. That raise is going really well. It gets us close to our goal of getting our first 2 satellites right into production, which will save us a lot of time. If we can start now, rather than a year from now or even a couple of months from now, we know that we can be ready to get on for a rocket to launch a lot faster. So we're extremely close to that. We're really about less than $100,000 away from getting our first 2 satellites in production.
Terrific. And then, so if all goes well, kind of looking out a few years, where would you like the company? What do you think the company would look like in, I don't know, 5 or 10 years? What's your vision?
5 years will transform the face of weather. Every time I see a hurricane on TV, I will see pictures from our satellites actually driving the coverage, as well as the forecast of it. I'm excited about that because that saves lives. So those are earlier forecasts, more reliable forecasts saves lives. So that's number one. And the other thing I see is just transforming these industries by giving them better tools to deal with the climate crisis that's happening right now. That's droughts, that's changes in weather that we just, the historical weather models just aren't what they used to be for predicting what's going to happen in the future. So we want to bring some certainty to that and just reduce the costs that industries are absorbing right now due to weather events.
Is there anything else in weather that you think where there's a gap? So I think I've noticed recently we've had quite a few announcements of companies wanting to put up microwave sounders. So I guess the actual ESA Arctic Weather Satellite we talked about, that's an example. But I think Spire also came out recently, said they're gonna do microwave sounders. Is that something interesting as well?
Oh, absolutely. So microwave sounders, the more of those, the better. And hyperspec. I have long been on the hyperspec train. I would love to, if the company evolves fast enough that we could actually do our own hyperspec constellation. I think somebody has beaten us to the punch. There's a lot of hyperspecs that are going up. There are some already in orbit, but there are constellations planned. But that's going to be huge for not just weather forecasting, but for some on-the-ground measurements that can then be put together with weather to help, again, like vegetation coverage is a big thing. And that affects mining, logging, shipping, farming, just resources in general. So that'll be huge to get that up there. And then weather is kind of like, how do you manage those resources that goes on top of these kinds of hyperspec things? And then the other thing that I would love to see is there's one satellite constellation now, but boy, methane emissions tracking, that goes into weather because, where did it come from to a level that's precise in finding out where these emissions are coming from. I think that would be a huge deal because emissions, a lot of times, people think that companies just want to, just emit willy-nilly. These oil companies don't care. Emissions actually cost them money, cost them hundreds of millions of dollars a year if they have a leak or things like that. So I think that the monitoring of methane emissions is going to be a huge application for hopefully what we want to do, saving lives and trying to reduce the damage to the planet.
Yeah. And you're saying the measuring of methane emissions, that's currently a gap, or it could be better?
Yes, there's one satellite constellation now, but there's one or two in the works, I believe. And I think that that's a huge gap for sure. It's not like a name and shame. Hey, we know that this company's doing this and this company's doing that. Yeah. But it really talks about production, reducing those leaks. And also methane emissions, it's really kind of like a real-time monitor that's independently verified of what companies are producing in real time. So I think that that's really exciting to me. I think that, I talk about stock trading a lot and commodity trading because weather impacts that so much. Mm-hmm. But boy, if you combine weather with this emissions and as a way of productivity, you'd really have an eye on the market to understanding what's happening economically.
Yeah. And speaking of those greenhouse gases, is there a way that the data you will be producing, again, the vertical winds and all of that, like maybe the longitudinal data, is that going to be relevant, useful for climate change analysis?
It will be, and I'll say that's a failing on my part to understand the impact there, because it seems like the producers, for the most part, don't feel the impact of climate change as much as the people that aren't producing. And our wind data will certainly unlock that a little bit. And I don't think I'll like what we find, knowing what I know already. But I think that's going to be, it'll be a powerful way to analyze that aspect of things. But like I said, it's just the producers aren't really feeling the impact as much as what we know already. And I think our wind data will prove that out to an even higher degree of, certainty.
I just realized I forgot to ask you at the beginning. You sort of mentioned at some point in time you liked this project when you came to it, but how did you come to this project?
So a few years ago, so I've been on the satellite bus manufacturing aspect of things. And when you're, a manufacturer of satellite buses, the first thing you have to do is understand what's the business case of this satellite project, or is there a business case? Because obviously, if you're building 1 or 2 satellites, that's a different price than if you're building 100 satellites, and understanding if their business model can scale to, 100 satellites, whatever. So these would come across my desk all the time, things that I would have to quote, things of that nature. And this just happened to be one of them that came across my desk. And I thought, well, a lot of people are trying to do weather satellites. So, I don't know that this is all that different until I started talking to somebody that was actually putting up their own weather satellites. And they said, oh, no, you should go back to that, because this hurricane aspect is it's a big deal. And what they're doing, it's not sensor based. It's looking at the clouds. So they actually eliminate a lot of the problems that traditional measurements are going to have a hard time tackling. So they get there a little bit quicker. So then I went back and I revisited it, and I started talking to the team a little bit more about what their vision was, how the technology worked, and learned more about it. And then I got involved. So that was nearly 3 years ago that I came aboard.
Okay. Yeah, I'm asking this because there's a couple of questions we always ask towards the end of the podcast. And so I'm going to ask you the first one now, which is basically if you weren't doing tropical weather analytics, but you have obviously space background, as you mentioned, satellite integration, what else might you be doing in space, assuming that you think space in general is an exciting field to be in? Right
No, definitely is. So I got into space almost a decade ago because I was developing biophysics instruments, and people were putting them up in space. And I said, ooh, I want to start going to these space conferences. So it was really an excuse for me to start going to space conferences and seeing what was happening. And the small satellite industry, drew me in immediately. And I'd go back, this is almost back in 2000-ish, 2010, that I started really getting interested in the small satellite when it was really just, kind of starting. So, and to see some of these shows that kind of didn't exist or were so small, grow is amazing. So I would definitely have been in space one way or the other. That this one, just in particular, I couldn't imagine ever having the chance to have so much of an impact with a satellite mission as this one, because it takes so much money and so much time to get here. And that already happened, that part already occurred. So it was like, well, it's just a small satellite project that actually just leverages years of knowledge, hundreds of millions of dollars of funding, and they're ready to go. So that's what drew me to this particular project. But I would definitely be in space in some capacity on the satellite side if it wasn't here.
On the satellite side, being sort of satellite integration or specific payloads or...
I think I'm always interested in the payload. I think that's maybe the biggest thing is, what's going to fly, what's new. It's just so interesting to me what people think up, and then the applications that can flow from there. And then, it happened to us. There are applications that you don't even know about until you start talking to certain segments out there in different industries. And then all of a sudden people tell you, big things like, well, forget about hurricanes, just measure the polar vortex. Those winds aren't in my models. So I think it's really exciting for those. I think that it's just a fusion of engineering and discovery, and then it goes to space. It's exhilarating. It's really exciting when you think about it.
Yeah, no, for sure. Agreed. Okay. Final question we always ask is about science fiction. And, do you like science fiction? And if so, any favorite science fiction? It could be anything, could be movie, TV series, books.
Well, I'm certainly a kid from the Star Wars age, so that obviously got me into it first. And then that always led, when I was a kid, there just wasn't, now there's so many things available. But when I was a kid, you had, one Star Wars movie, and then that was it for a long time, and then the other two maybe. So that led me to, where's more of this? And that led to, Star Trek, Isaac Asimov, which then led me to Carl Sagan. I still see those. So those are some of my favorites for sure. And my introduction to it, those just still hold a certain place, even though some of the content has gotten slicker and nicer. Those classic stuffs just kind of get me in a certain way, and I kind of always, it feels like the original Foundation's part of it.
Oh, Foundation is great. But Star Wars, now that I think about it, it seems like the weather prediction capability wasn't that great, right? I'm thinking there was like these like snowstorms on Thoth, and they weren't really predicting it, and it was like sandstorms on Tatooine.
From a practical matter of things, they could have used weather prediction a lot better. I don't think they use their assets as well.
There you go. Well, on that note, Dan, thank you so much for being my guest today, and best of luck with the rest of your race and launching your first 2 satellites.
Thank you so much for having me on. I appreciate it. I'm a big fan of the podcast, so
thank you.
I'll be excited to see how this comes out.
All right, take care.
All right, thanks. Good luck.
And that's a wrap for another nominal episode of the Space Business Podcast. Once more, if you enjoyed this, please leave us a 5-star rating on your favorite podcast platforms such as Apple or Spotify. You can follow us on Twitter at podcast_space. You can support us at www.patreon.com/Space Business Podcast. Lastly, if you have any feedback, including ideas for guests, and that may include yourself if you have an interesting space story to tell, or interested in being a sponsor, drop us an email at spacebusinesspodcast@gmail.com. See you for the next episode.